All right, John. First of all, thanks for the opportunity. It's really a privilege to have this opportunity to talk to you. And certainly, you have had a great impact in the bridge engineering. And I thought you would be an excellent person to talk to kind of provide the general public where we are at with the bridge engineering and what are the important issues and so on. So in that respect, I really appreciate we are in the Atlas Center here at Lehigh University. So probably one of the best universities in the world where many new concepts in the bridge engineering really was born. So as a way of a start, I wanted to, I know many of our audiences, even within our own profession, would like to learn a little more on the your private side, where you got your educations and the path that took you to where you're at here. So if I may, I would like to take you back to your kind of childhood, and then if you could tell us a little more about where you went to high school, and so on.
Okay.
That would be great.
Well, it's a very diverse condition. My father worked with the Army Corps of Engineers, and we moved to Hawaii in 1941. And we didn't return from Hawaii until my father had to, he was a dredge master, he had to go clean out the harbors in Tinian and Saipan. So I'm the oldest of 12, or 11 rather. I'm the oldest child of 11 children. There were 5 of us when we moved to Hawaii. 2 of my sisters were born over there, and we returned to Missouri, which was the birthplace of where I was born in southeast Missouri. So that was 1945 when we returned to the U.S. And so I attended high school at a small village in southeast Missouri, near the Mississippi River. And I graduated from high school in 1948. And because it was a large family, there were not many resources available. I did attend Southeast Missouri State College in Cape Girardeau, Missouri, which was a few miles from where I was living. And I ran out of money. And so I went to work on the Mississippi River. I took a job as a tankerman, loading fuel in barges, traveling the Mississippi River from New Orleans to up as far as Minneapolis, St. Paul. Well, I attended college 1 year at Cape Girardeau at the Southeast Missouri State, and then I decided I had ran out of funds, and so I took this temporary job, and then I decided to go into the military. I joined the Army. I did that in 1951, and I was sent to basic training in Camp McCoy, Wisconsin. I had a girlfriend that lived in Missouri, who became my wife. But in any event, I was selected after basic training to attend the Officers Candidate School at Fort Belvoir, where for engineering, and I graduated from the Fort Belvoir, where the school was, and that was in the summer of '52. And so I was then sent to Fort Leonard Wood in Missouri. At the time, I was 21 years old, and I decided while I was in Fort Leonard Wood that we would marry. So in October of 52 rather, I married my childhood sweetheart, and so we just celebrated our 72nd.
Congratulations.
This past October. Well, then I was sent to Germany as a lieutenant. Of course, this was during the war was over. I was at a Hessen-Hamburg concern in Hanau, which is a village 10 miles from Frankfurt. And so, fortunately, the Korean War came to an end, more or less, and so I had 1 year of college that I had attended, and so I decided I had the opportunity to resign from the military if I had an opportunity to go back to college. My wife I was in Germany a year, and there was no housing or anything, so it was not possible to bring her spouse there. So she had subsequently had gone to work for the FBI in St. Louis. And so I decided that I would resign my commission to get out of the military so I could attend college and finish my degree. And so that's what I did. I resigned the commission. I was able to, they flew me back. I got out of the military and sent me to St. Louis on a train from, I think it was a military base in Kentucky that I was sent to. And then I enlisted and went into Washington University in St. Louis. So that's where I got my initial engineering degree. At the time, most of my classmates were vets. Fortunately, we were on the GI Bill, so that assisted me. My wife was working with the FBI. And so I finished my degree in 1956 by going summers. I never took any time off. And then the faculty at Lehigh, the faculty at Washington University wanted me to go on to graduate school. So they urged me to go to Lehigh.
So they recognized the talent very early.
So I did. So I accepted a graduate fellowship from Lynn Beadle, who became my advisor. And we journeyed from Missouri to Pennsylvania, here at Bethlehem, Pennsylvania. And so I started graduate work that fall in 1956. I was working on limit states, plastic design. That was the primary focus here at Lehigh as a graduate student. So I spent 2 years as a graduate student, and then I accepted a position as the assistant bridge research engineer at the ASHO road test in Ottawa, Illinois. So my boss was Dr. Ivan V.S., who was a former faculty member at the University of Illinois, and he had left and accepted the position. So I spent 3 years as the assistant bridge engineer, and it was that experience that led me to my greater involvement in bridges.
Okay.
Because it was up to that point, the test road demonstrated that fatigue was a possibility, because most bridge engineers in that era did not think fatigue existed. They thought the design was sufficiently robust that it was not going to ever lead to cracking.
Can you, John, explain to our audience the fatigue, our audience, especially the ones that are not engineer, that what was the problem that you saw, and which is fatigue? Can you explain that a little more?
Yes. Well, the bridge we had as part of the road tests, which were trucks driven by the U.S. military crossing on a circular, well, it was a straightaway and with circular ends that the trucks could maintain speed. And so there were a total of 4 bridge sites in each end of the structure, so that the trucks crossed these bridges. And there were composite bridges, non-composite bridges, and concrete bridges that were on a total of, I think, 18 bridges total. And so these trucks circled for 3 years. And it was, since I was the assistant bridge research engineer, I was responsible for making measurements, and we had many young trainees with the Federal Highway Administration that spent time there. So it was the test road where I got involved with bridges, and as a result, many of the bridge engineers of that day were aware of the test road. We had a number of people that were assigned to maintain and serve on committees so that we could update.
So John, during that time, like you said, so during those tests you would see that, for example, you have a piece of steel in a bridge, and then you apply this truck goes over it
Right.
time and time again, and then it starts cracking. Did they also observe the same thing in the field too?
No, at that time there was no experience that anybody had identified.
So it was just in the...
It was the
test.
cracks that developed in the test road at these cover-plated beams. That was the first known, and in fact most engineers at the time, because fatigue was considered kind of like a black box.
Yeah.
They made use of the design made use of not directly stress range. It was a more complex thing that was put forward as a design criteria. And so most engineers did not believe fatigue was a design problem at that time. And so the test road was the first one that sort of brought it to the fore.
Okay. So we'll come back to that one. Let me ask you one question. So bridge engineering was something that you were always interested in engineering? Did you have an interest in other areas too, or just?
No, I'd say my primary interest was in civil engineering in general.
Okay.
When I went to school, I had no idea that I would eventually become more focused on bridges until I joined the test road. Because up to then, my initial graduate program was dealing with plasticity, and my thesis was actually on connections. And so I was more involved with plasticity. While I was at Lehigh, though, I did develop a lot of friendship. There were a lot of students from around the world, Japanese, Chinese, Europeans from Switzerland, Germany, France, that came to Lehigh to study limit states, plastic design as it was called. And so fatigue was not a big issue at that time. And so I had left Lehigh and went to join the test road for 3 years. And then Lynn Beadle wanted me to come back to Lehigh to work on a doctorate. So I went back to Lehigh in I left in 58, and I came back to Lehigh in 1961. At that time, we had one child, a son that was born while we were in Illinois at the Asho Test Road. So, but it was the job of assistant bridge engineer gave me an opportunity to meet many bridge engineers who came to see the test road and also served on the committee. So it so happens the test road was finished in 1961 when I returned to Lehigh, and at the same time, Ivan B.S., who was my boss at the test road, he left and went to work for Bethlehem Steel. And so he also moved to Bethlehem. And so I had a long association with him. And so as a result, after I came back, I was initially working on high-strength bolted joints. That was the primary objective of my initial research work. And so as a result of Ivan coming back to Bethlehem, working with Bethlehem Steel, then we both became involved with the Transportation Research Board, which was the test road source. And we also got involved with many committees of ASCE, the Transportation Research Board. So that provided my interest in bridges started at that time.
Okay. Let me ask you, John, you've seen, if you look back, the educational system, how do you compare the educational system that you came through and what we have right now?
Well, it's vastly different in my view. One of them is cost. I went to college under the GI Bill. And in fact, it's almost mind-boggling when I think the tuition at Washington University and at Lehigh was around $600 a semester in those days.
Not anymore.
Today, we're talking 50 to 60 or 70,000 a year, rather than 600. So that's one major change that has happened. The cost of education is vastly different because I can't believe that the rate that we were paying in tuition in those days has grown to the multiple thousands that we have today. So as a result, that allowed me to attend school, since I was attending school with the support from my military service, the GI Bill.
How about the way we teach the student in engineering? Do you see the system we had in the past compared to now? How do you?
Well, when I was working on my undergraduate degree, most of my classmates were veterans. We had a few younger men who had not gone in the military that were there, but for the most part, most of my classmates were veterans as I was. So my age was 3 or 4 years more than most of my other classmates. So that was, and as veterans, I think we were more focused on getting an education and getting it done. So I went to school 12 months a year, and that's why I was able to graduate in 1956.
You know, nowadays there are several articles. There are many disruptive technologies are being introduced. For example, let's say autonomous cars. There's a drone. So now actually there are companies that are specializing in taking with the drones basically the passenger from point A to point B. And there's a talk that it may not address all the transportation issues, but maybe 20-30% of it.
Yeah, they're tools. I look at them as tools.
How do you think that is going to affect the bridge engineering in the future? I mean, for example, if you have autonomous cars or drones, for example, taking people from point A to point B and all that, do you see any influence of that in the way we approach the design construction of the bridge? I mean, rather than 4 lanes, are we going to be looking at something different than that? Effect of these disruptive technologies?
Yeah, I think there's changes that technology makes possible. For example, when I was in school, our calculations were made with slide rules. We didn't have computers. My first exposure to a computer was at the Asheville Road Test, because we did have a Bendix G15, I think it was called, that we made use of. And so when I left the test road and went back to Lehigh, no one at Lehigh had any experience with computers. So they were still using slide rules and these machines that were available to run calculations. In fact, I taught the first course to civil engineers as a student. I was a graduate student when they asked me to do it, because none of the faculty had any experience with computers. So the computer has made massive changes, but fundamentals, calculations are much easier than the time spent cranking a machine.
Right.
That was in my era, but I'm not convinced that it is assisted. I have a feeling sometimes that the computer has made it so easy that people forget sometimes some basics and overlook things that they shouldn't overlook.
The ability in the back of the envelope to actually do some estimate. Yeah.
So there's pluses and minuses, but that has changed significantly. So we have tools today, but the tools do not prevent us from making mistakes. We are dependent upon our brains and what our experience has, and that I see goes in cycles. I don't think, for example, education is not continuous. Sometimes we don't even offer a course anymore in fatigue, because people assume it's available on a computer, and so it's going to provide a solution. So that's part of the problem. Technology has limits, and if we do not attend to details, and frequently we don't. I mean, that's why we had a bridge collapse in Pittsburgh from corrosion, because we still do not maintain bridges to the degree that we should.
So, John, that brings me actually, while we are at the point, I mean, you've been involved in many bridge cases, sometimes complete failure, sometimes just a minor. And you've been very much involved in investigating the causes and so on. In your experience, uh, uh, which, if you were to going to pinpoint one case that you were involved that really influenced the bridge engineering, can you briefly elaborate on that? Which case was that, and how it influenced the bridge engineering practice that we have nowadays?
Well, I guess fatigue raised its head initially with cracks that formed in the Yellow Mill Pond bridges in Connecticut on I-95. And it was they had one beam had cracked, but they didn't even realize that the whole bridge had multiple cracks and many spans. So that was one of the early ones. But the one that I would identify as classic was also on I-95, the Mianus River Bridge, that collapsed and led to, because it was hangars, and corrosion had in fact developed to the point that it had pushed the hangers toward the ends of the pin that held the hinge joint, and that the plasticity initiated a crack and the pin sheared off because it was the inspectors had not properly identified the detail. So I think that collapse, to me, demonstrated that, and it still holds today. I don't think corrosion is adequately dealt with by the profession. Everybody assumes when they build a bridge and they paint it, that's all they need to do. And so they don't look at what happens with time as the bridge gets older, and because we're not going to stop using salt water to maintain the roadways.
That's right.
So we're continually drenching the structures. We are not keeping them clean. I don't see a big focus still on that. Why we had the bridge collapse in Pittsburgh. Well, I think I look at it as a cycle. I think what happened is in the 60s, when we started, 60s and early 70s, we started having major problems with cracking. And so that's why I became involved with cracking throughout the United States. Much of it here in the East, but in the Midwest, Illinois, Ohio, Kentucky, bridges all over the country developed cracks, for one thing. This problem in fatigue was more serious than what was originally thought. And then coupled with corrosion, it led to possibilities that caused cracking from pushing pins to the end until finally the bridge collapsed and we had loss of life. So we have been fortunate that we have not had too many collapses that led to loss of life. And so that has, obviously the big bridge across the Ohio River in Wheeling, that led to, because it was an I-bar failure, again, corrosion had a role in it, that led to collapse of the bridge.
Do you have any advice for students that are looking at being an engineer or a bridge engineer?
Well, I think one, they need to have a solid education. and that probably means at least a master's degree. And then I think they need to also, I'm not sure how we solve the issue, but the transfer of knowledge from engineers who have dealt with the system for 30 or 40 years and then they retire, and the new people are not completely up to date on what the system is, and so that's why these surprises are occurring. I think the knowledge transfer is not uniform and consistent. And so I think the tools we have today are better, a lot better than what we had available in my era. But it's a transfer of knowledge is difficult to achieve. And I think that is what is leading to sometimes problems have surfaced, and the consequences of them are not fully understood. And so people retire, new people come in, but in the bridge engineering field, you have a lot of change. And it's not only the staff of the different departments, but it's also the engineers from private companies that are doing a lot of the design work.
So, John, let me ask you another question. We have, in every state, we have one state bridge engineer that's in charge of maintaining all the bridge in that states. And of course, we have lots of check and balances, federal highway administration, we have US DOTs, and we have the national organizations, and so on. In general, do you have any thoughts that you would like to share with them that what maybe we should do to improve the system?
Well, I think the issue of corrosion and fatigue are always going to be with us. And it's how do we transfer knowledge of specific bridges, often where we've allowed the corrosion to the point like the original Tappan Zee Bridge. I mean, it was mind-boggling how they had not kept the structure clean, and it was essentially corroding away on all the spans, the original structure, to the point that they ended up replacing the whole structure, and that started, 6 or 7 years ago, and now it's finished. But there's issues that have been observed. So there are potential problems that exist. Now, the question is going to be, though, management makes decisions on allocation of resources. And so, especially a new bridge, which we expect to have maybe a 100-year life today, are we going to maintain it over that 100 years? Is one of the issues. Are we going to maintain it adequately? Because I think that is, it costs money to maintain things. And I don't think we often are making the investments on structures as they age. We forget the potentials that exist. And so, and it changes because the management changes. And so particularly a bridge like the Tappan Zee, the new Tappan Zee, has been designed for 100 years. So the question is, 100 years from now, what is that bridge going to look like? Are they going to maintain it? Because it costs funds. It costs a lot to maintain major structures. And I think that is one of the issues that comes from allocating funds.
That's right. The maintenance is just like if you buy a new car and if you don't change your oil, I mean,
Right, that's
soon you're
right.
going to have it. You're going to have to change your engine. That's certain. Okay.
And I guess engineers do. I'm convinced most engineers, whether they're private consultants or they have knowledge, but they sometimes don't have experience related to it. So knowledge alone will not. Some of it is only acquired through experience and the depth of what you need to know.
Yeah. All right. Okay, John. I mean, it was really a pleasure, and it was a privilege to have this opportunity. So I really thank you for the time that you spent, and it was you went through lots of material, but I know that I wish we had much more time to go through many other points that I know that many in general public and within our own rank are interested. So thank you for the time and thanks for the.
Well, it's been my pleasure to talk to you on this topic and topics, and unfortunately, at the age I am now, I'm not as
You look
active.
very good, so.
But as long as my mind allows it and my health, I guess I will keep doing it.
Oh, thanks a lot.
So it's a pleasure to have had the opportunity to deal with these questions from you.
Thank you.
I wish you success in your own activities as you pursue
Thank you.
your career.
Thank you.